Hello, just wanted to start a lecture today using Cornell notes. Name, class period, and date, pretty standard. On the topic and objective, we're going to start by calling it lecture. And let's see, this is intro to the concept of scale. Okay, just follow me as we do this and keep up. The first essential question is how do we understand the vastness of space? When we're beginning, that normally is a big problem trying to get our heads wrapped around how big is the universe, what is the scaling, etc. So let me start by talking a little bit about scaling as our intro lecture, if you will. So let me zoom in a little bit and hopefully you can see okay. Okay, so first of all, the concept of scale is critical in astronomy. Okay, if you understand, let me zoom out a little bit. If you understand scaling, then you'll be able to put things in perspective as we look at things in space. So scaling allows us to see, in quotes, or perceive the objects in space in context. Because the scales are so different than what we're familiar with. So things like, for example, when we change colors, planets, the sun and the suns, I'll put it in plural, solar systems, galaxies, clusters, and superclusters. Filaments, etc. So basically it gives us, by using proper scaling, it allows us to get at least wrap our heads around some of these concepts. The idea is that the universe is so huge it is foreign to our normal daily living. For example, things like we think about things like kilometers, miles. We talk about and think about in inches or centimeters, etc. Different than what we're normally used to. Now, the units used in astronomy The units used in astronomy are metric, astronomical unit, AU, abbreviated AU. We'll get further definitions as we move on. Light year, parsec, P-A-R-S-E-C, parsec. Okay, you get the idea. Now, as we move on into the scaling, we have to talk about the metric prefixes and give you a little bit of background on that. So I'm going to switch colors to black. And let's talk about metric prefixes. Okay, and I'm going to give you 4. Let me use a different color altogether. The prefixes would be giga and abbreviated G. It's 1 times 10 to the 9 power. Mega, capital M, 1 times 10 to the 6 millions. Kilo, abbreviated K, 1 times 10 to the 3 third power. Deci is D, is 1 times 10 to the negative 1. Okay, I'm going to continue in the back. So you can always stop this at any time or ask your teacher to stop it if you're watching it in the classroom. So we're continuing metric prefixes. So in the back, you have milli, and in this case it's M, 1 times 10 to the negative 3. Micro, which is U, micro, 1 times 10 to the minus 6. Nano, which is small n, 1 times 10 to the negative 9. Now, the international system is called SI. You're probably familiar with it. SI is the international system. And in this case, I'll tell you the physical quantity and how we measure it and what we use. So let me switch over to green. So let me do the physical quantity. And in this case we'll say length, mass, time. These are the physical quantities that we measure, and I'll give you the international system's usage. Temperature, electric current, light intensity, amount of substance, and in this case, let's go out. The length is meter, abbreviated M. The mass is kilogram, abbreviated kg. kg. Time is second, abbreviated S. Temperature is Kelvin, abbreviated capital K. Next one is ampere, abbreviated A. And let's see, let me let's see, light intensity would be candela, abbreviated CD, and then amount of substance is mole, abbreviated MOL. Okay, so that will give you at least the basis in terms of scaling, and we'll wrap up making sure that conversions is an important skill. Conversions is an important skill. We'll work through problems along these lines, but we will develop. Thank you very much. I hope you guys get the notes down, and we're done with the first lecture. Thank you.